Okay, we are doing representing relations and functions today. We have another very easy lesson ahead of us. So let's really quickly review what function notation is. Ooh, my whiteout is not dry yet. Function notation. That's all right. We'll just go right below it. There. Okay. Let's make sure you can see. All right. So function notation. So if we have something like y equals x plus 3, that is not function notation. But if I write it as f of x equals x plus 3, that is function notation. Shh. F of x, yes, correct. Now, there are a couple of, well, no, there's really one other variation of this that is, so I've gone through several higher levels of math beyond this, and I've never seen this one used, but it exists apparently, so we'll write it down. F colon x, that's the same thing as f of x with parentheses. So you can say either f of x, f at x, typically it's f of x though. Okay, so let's go through some special functions. We're not actually going to graph these in this. I'm going to show you what the graphs of them look like, but we're not actually going to spend a lot of time graphing these. All right, so the first one. First one is f of x equals c. So this is a constant function. So something like, whoops. So something, so an example would be f of x equals 3, where it's just a number by itself. That's the same thing as y equals 3. So does anybody remember, if we were going to graph it, how we would graph y equals 3? Let's see. O'Brien.
It would be a horizontal line on 3 on the y-axis.
All right, everybody give it up for O'Brien. Nicely done. 3 on the y-axis. Good. Okay, next one is what's called the identity function, and that is f of x equals x. This is the one that people always have trouble graphing, and it is the easiest one to graph. I think us mathematicians tend to make things more difficult than they actually are. So, same thing as y equals x. Well, if we were to graph y equals x, that is the same thing as x plus 0, thank you, x plus 0. So our y-intercept would be at 0. Let me use a different color here. And we would go up one, right one, up one, right one, up one, all the way. So it's just like that. Y equals x. That's what I always get questions about. All right, next. F of x equals the absolute value of x. This is the absolute value function. So we should have seen all of these before. Absolute value function. Anybody remember what the shape of the absolute value function is? So we've done this already a little bit. Ah, good. I see people going like this. That's good. It's a V. It is a V. Let me move that up. V at 0. Why is it a V again? Can someone remind me why it ends up doing that? Maxie?
Is it because there's positive and the same thing, they're like opposites? So
Okay, that's one explanation. Everybody give it up for Maxie. Alexander?
it's an absolute value.
That's okay, good. So it's an absolute value and it can't go into the negative values of y or f of x. Everybody give it up for Alexander. Very good. All right. Can I change the paper? Are you guys good? What's up, Matson? To keep track. Keep track.
Much easier.
Is it easier?
Yes.
Good, okay, that's good. I'm helping out our scorekeeper here. Give it up for our scorekeeper, Clark. Clark. All right. Okay, here we go. Let's move this. All right, last one. This is one that you all have never seen before. It's called f of x equals, and there's square brackets around x. Square brackets. So we have not seen this before. We may have used those as parentheses or grouping in some way, but as far as a function, this is what's called the greatest integer function. It can also be called a step function because the graph looks like a step. everybody's irritated with the air conditioning. Actually, not everybody. Underhill is irritated with the thing.
I know! It's angry.
Well, yeah, I know. Okay,
It's like a giant angry bee.
so this one we're actually going to put in... Here's what we don't need to worry about the graph all that much. I'm going to explain it, but we don't necessarily need to worry about it that much. What the greatest integer function does is it takes any decimal or any fraction and it's like it scoots it back down to the next greatest integer. Meaning, if I say, okay, what is the greatest integer of 1.5? The greatest integer within the number 1.5 is 1. Okay, or the greatest integer of 2.5, or let's say 2.8. Greatest integer of 2.8. 2. Okay, so the way the graph looks, again, we're not really all that concerned about this, but I'll put it up here anyway. What you end up getting here is a series of steps that look kind of like this. Okay. Because, okay, focus on it. Can someone explain, does anyone think they can explain this graph and why it looks like this? Unger.
Well, you have a solid dot like on the first integer, but as it goes up, there's an open circle around the next one.
Yep.
Because it isn't that next integer, but it's like that space between the two, including the greatest integer.
Okay, good, very good. Good explanation. Everybody give it up for Unger. All right. Again, we don't need to worry about the graph so much as this piece of it, which is what greatest integer does as far as to specific numbers. All right, so check out how easy this is. Here are our examples. It's not that. For f of x equals x squared plus 1 divided by 2, we want to find a few things here. We want to find f of 1. You can't see that. Okay. Find f of 1, f of 2, f of 1/2, and f of t. All right, so our function is f of x equals x squared plus 1 over 2. All right, so can somebody tell me how I would go about finding f of 1? This should be review for all of us. Ram. Exactly. All right, give it up for Ram. Put the 1 in for x. Everybody give it up for Ram. All right, here we go. Ready? Shout it out. What is 1 squared?
1.
Plus 1?
2.
Divided by 2?
1.
So f of 1 is 1. Okay, let's go through the next one. F of 2. What do I do to find f of 2?
Plug it in.
Plug it in, plug it in. To what?
Same thing.
Good. Matson Bose. Everybody give it up for Matson Bose. All right, here we go. Ready? Everybody shout it out. 2 squared is?
4.
Plus 1?
5.
Is 5 evenly divisible by 2?
No.
So we can leave it as 5 over 2. Oh my, hello.
Hi.
Thank you.
Cody Lynch is so obnoxious.
Oh, well that's just not very nice. Okay.
But you called him Cody Lynch, so.
Oh, so that cancels out the...
Yeah, we're buds.
Got it. All right, what about f of 1/2? What do I do there?
Plug it in.
Plug it in for x again. 1/2 squared plus 1 divided by 2. This, I know you all love fractions. This is my gift to you. Okay, 1/2 squared is?
2.5.
1 over
1.
How about 1/4?
2.5. You meant 0.25.
Okay, so think about it this way. When you square something, it's multiplying it by itself, right? 1/2 times 1/2. You multiply the numerators together and the denominators. Now, am I worried yet? I was worried a long time ago. Okay, so 1. So how would I combine 1 and 1/4? Yeah.
You just add them, make them
Shh, you guys, everybody zip it. They get what?
You make the denominator of 1/4, then it would be 4 over 4, and then just add them.
Good. 4 over 4, which is 5/4 divided by 2. Do you guys remember the trick that we talked about with fractions?
Multiply it by the reciprocal.
Okay, that's good. You can multiply by the reciprocal, which also ends up being the denominators multiplied by each other. So this comes out to 5 over what? 8. Good. All right, how are we doing on questions? Pretty self-explanatory?
Wait, hold up.
So if you think about 5/4 divided by 2 or 2 over 1, that's the same thing as 5/4 times 1/2, right? Which comes out to 5/8. So the trick is to just multiply the two denominators together. Okay, one last one. Yes, question?
If you have 5/4 and you multiply it by, oh wait, I lied. Never mind.
Okay. F of t. Okay, so what do I replace x with? T. So who can tell me what I get for an answer? There's not really any simplifying here. Clark. Excellent. Everybody give it up for Clark. All right. Let's see. Okay. Let's go through this super easy. You know what? I will put these up and then I will ask for volunteers because they are so easy. You don't really need to have them explained to you. Okay, so here we go. Here are the next several. For f of x equals the greatest integer of x, which we just talked about, we want to find the following things. So the things that we are finding are f of 0. I'm going to ask for several volunteers and we'll get our think music going here. F of 0.5, f of negative 0.5, whoops. Let's see, f of 2.9, f of negative 2.9, and f of pi. What is the number pi again?
3.14159.
That's good.
Y'all are robots.
They are not memorizing that. There is a poster on the wall. They're still going. Okay.
419.
All right. Do we need to take time to think about this? Do I have volunteers that want to come up? All right. Let's see. 6 people come up right now. Whichever 6 get up here first. I can do it. Oh my. All right. So can you keep track?
No, but I'm 3.
That's still only 3. Go for it. Just do the first. What the first one?
Okay.
Do I have to like write it out?
No. Just tell what the answer is. Okay.
Wait. Before
You guys stand over to the side.
Before I write that, I want to know if I'm right. I just got 0.
That's right. All right, everybody give it up for Maps and Bose! Yay! All right, Unger, you're up. Yep. All right, everybody give it up for Unger! Yay! Okay. Next one?
What?
This one actually goes to
So
negative
what?
1. Wait, what?
Wait, you don't want to plug it in?
Goes to negative.
Well, yeah, so
Wait.
just divide it?
Yeah.
Okay.
All right, everybody give it up for Rosander! Yay, Rosander! You can explain that if that's confusing to people a
That is
little bit.
confusing.
Yeah.
Uh-huh.
All right, Maxie, go ahead.
1, 2, 3.
Wouldn't it just be 0?
We'll all explain.
All right, give it up for Maxie! All right. Alexander! Okay, so this one's negative 3.
Like 1, 2, 3, 4.
I'll explain why. Just go to Maria.
Don't explore some state. What are you doing? What are they doing? Of course,
All right, everybody give it up for Alexander! All right. Johnson!
Got this,
Jay. And then one goes down to what's the biggest piece?
Shout out to Miss Lee, Miss Me, Miss Barnett, and Mr. Humphrey.
Jack,
Cool.
I don't know.
square it.
Yeah, but it's
I
all
don't
right, everybody give it up for Johnson! Yay! Okay, so there was some confusion, I'm guessing, about this one and this one, yes? Cool, let's explain that. So let's think about, okay, let's draw a number line up here, okay? So if the greatest integer function, let's see, 0, 1, 2, negative 1, negative 2, negative 3. All right, so if we're looking at 0.5, the number 0.5 is right here. The greatest integer within 0.5 goes back down to 0, correct? Everybody see that? Okay, just like with whoops, let's go over a little bit. 2.9, oops, that's kind of low, sorry about that, you guys. 2.9 is right in here somewhere. That the greatest integer within that is 2, right? With negative, you see how it always goes back down to the next greatest integer? It's always rounding down, exactly. So if we're looking at negative 0.5, if you round down, the next greatest integer is negative 1. Does that make sense? Just like negative 2.9 is right here, the next greatest integer is negative 3. Does that make sense? Okay, questions? Okay, last example. Nope, sorry, second to last example. Yes, Matson Bose, what's up? Oh yeah, that's not usually up. This is our backdrop for the game show. We're quasi-game show today. Okay, here we go. Forgot about that. Function notation. Quasi-game show. All right, here we go. Use function notation. Everybody zip it. Shh. To give a rule for the pairing over the given domain. So we only have to go through a couple of these if you guys understand. For the pairing over the given domain. Okay. All right, so we're going to be given a bunch of coordinates here. So the first one, 1, negative 1, 2, negative 2, 3, negative 3. Okay, and here's what we're actually being asked to do in this problem. I'm sure you all can see. 1, negative 1. We are being asked to write a rule, meaning f of x equals something, to show how you get from the x coordinates to the f of x coordinates. Okay, so the x coordinates in here are 1, 2, and 3, and the f of x or y coordinates are negative 1, negative 2, negative 3. So can anybody, if we're looking across here, can anybody see what happens to get from x to f of x in each of these pairs? Multiply by negative 1. Excellent. Give it up for Matson Bose. So to get from x to f of x, we have to take the x and multiply it by a negative 1 or negative. Does that make sense? So that is the rule, function notation rule for that pairing. Do you want to do another one?
Wait.
Negative
Can I
x.
do a hard one like where it
negative 1, and then it would be x.
Okay, so what if we have something like this? 3, 6, 2, 6, negative 3, 6. Okay, so let's see. I don't need to write those again. X and f of x, we've got 3, 6, 2, 6, negative 3, 6. You guys tell me, what is there, what can people think of? Feinerman?
I have a question.
Yes.
So for the first one,
Uh-huh.
if we multiply by negative x, does that mean the actual x, like 2 times negative 2?
1. Yeah, so all you're doing is it's saying take what's in the x column and attach a negative to it.
Okay, so by the negative x, it doesn't actually mean the number x. I mean,
Yeah, so in other words, if you plug in the number in the x column, you should get what's in the y. So if you plug in a 1 into this expression, all the Okay. Okay, other questions? So what do we think about this rule? Anybody have any ideas? So no matter what x exists, you always get a 6. So what do we think? Ram? Sort of. Again, we're relating f of x to x in some way. So f of x equals, again, what does f of x always equal in this column, no matter what? 6. So can I just say f of x equals 6 regardless of what x is? Oh my. Okay.
What's the equation then? 0 times x plus 6.
What's that?
Wouldn't the equation be 0 times x plus 6?
You could do it that way. 0, but then you want to simplify. Yeah, good. So what Unger just asked was, wouldn't it be something like 0 times x plus 6? Yes, but you want to simplify. 0 times anything is 0, plus 6 is 6. So yes, very good. Okay, you want to do another one, or are we good with this?
We're good. We're good.
All right. Last examples. Ooh, okay. We're going to turn that into a 4. F of x equals x minus the absolute value of x plus the greatest integer of x, find the following. F of 3, and let's do one more after that. F of 3 and f of 8.2. It's an x. So I'll write on the right side here. F of x equals x minus absolute value of x plus the greatest integer of x. And we want to find each of these things. All right, so can somebody tell me what we're doing in this first one? Ooh, this is a longer video than normal for you guys.
Very long video.
Underhill is dying over there. Okay. Well, we've done this before. So what are we doing with, what do we do? Here. Plug it in. Good. So plug, in this one we're plugging in a 3. So 3 minus the absolute value of 3 plus the greatest integer of 3. So what is the absolute value of 3?
3.
What's the greatest integer of 3?
3.
So if we go left to right, 3 minus 3? 0 plus 3? Okay, how about the next one? F of 8.2. F of 8.2, I'm going to write it down here. So I'm plugging in 8.2 minus the absolute value of 8.2 plus the greatest integer of 8.2. All right, so what is the absolute value of 8.2? 8.2. What is the greatest integer of 8.2? 8. Awesome. Okay, so what do we get when we... 8. All right, cool. Any questions? All right. So let me go ahead and put your homework up here.
Good lesson, guys.
Yes, nicely done, everybody. Everybody give yourselves a round of applause for your awesome work. How about everybody? Yeah, everybody give yourselves a round of applause. Everybody give yourselves a round of applause. Okay, all right. So, oops, let me go and write this up here. I have to write it up before you guys can go ahead and get started. 9 to 36, multiples of 3, and 63 to 75 odd. There you have it. All right.